Good morning, everyone. And it's actually a good demo to do after the previous talk, because now we had a chat on the platform. Now we're going to move over to the other piece, the data definitions piece. So my name is Zak Kerls. I am a software engineer at Chevron and I'm the lead of the dynamic reservoir modeling data definitions group. And today, a team of us are going to go over our MVP1 results and give you a quick demo and a couple different applications of our work in action. When you go to data definitions groups, you often will see lots of spreadsheets, and we're debating over how we want to standardize the data model, because if you have standardized data endpoints, but the data comes back differently, it's not going to be helpful. So we standardize the data by working together with a group of many companies in order to unite, finally. So today, we're going to actually showcase, instead of showing spreadsheets, we don't want to do that, it's kind of boring. We're going to actually showcase our data schemas in a couple different products. Two of them are going to be vendor products. One of them is going to be a custom UI we built in order to validate our schemas. But first, we're going to try to set the context of it. So I'm going to pass it off to my colleague here, who's going to go over our agenda and our MVP1 workflow, so you'll have an idea of what we're going to work on, or what we're going to show before we show it.
Thanks, Zach. All right. Can you guys hear me okay? Yeah, I'm mic'd up well. Okay, I'm Jennifer Rainey. I'm the data modernization advisor for reservoir management at ExxonMobil, but I am also the lead for the reservoir management meeting for the DDMS. Zach is the lead for the dynamic simulation as well. And so we have been leading kind of these meetings to get through MVP1. So kind of the agenda today, what are we doing? MVP1, we're going to review all of the work that we've done this last year. We had a face-to-face at Chevron in January, and then we put a plan in place and have been working super hard with multiple companies to ensure that we get those schemas written and our WPCs and our activity models to be able to get this done. We'll go over that a little bit. Next up is a demo for the data workspace. This is really to show the catalog, our lineage, our, I can't think of the word. But really the next one is IVAP. We'll do a visualization of the content over multiple DDMS. So it's not just the rocks and fluids. Next up is the custom app. This is created by Zach, and so we will actually kind of show how we can look at our content schema. And then we have a commercial demo that Faroukh is going to do for us that shows, how we actually can use that schema with a commercial product. And then finally, we will go over, we had another face-to-face at Total in October, late October, and we're going to kind of go over what our next ups are, right? How are we going to get this to the finish line? And so, and ultimately, we'll have a Q&A at the end. So can you go to the next? Oh, I have it. There we go. OK, so this is our MVP1. What do? We really got together and we thought, what do we absolutely need for initialization, right? To how do you put a for simulation when you actually put something in. So we did an equilibrium model, and we only focused on that. So we have the inputs that we need. We didn't rework anything that was already created. We just pulled. You can see the stuff that's on the left and the stuff that's on the right. Both on the inputs and outputs, some of that stuff was already done by other teams. We're not going to rework it. We're going to pull and use other people's work. But you can see kind of the inputs here. We had for both rocks and fluids, the inputs that you need for your simulation. You can't just use the lab data. You have to have an interpretation of that. So we created a place for that. We have the equilibrium model. So that's what we would do for our initialization. And then we have the information that we need just to run a reservoir simulation. So we have the activity model, just our regular model, and then the run configuration as well, kind of the data about the data. So. You want to go to the next thing?
Yeah, let's do it.
Hand it over to Zach.
OK, so what we talked about in the last section, we talked about that platform. And we talked about how we have our DDMSs for that optimized content. And then we also have our catalog. So OSD really started as like a catalog. You can put unstructured documents into this data platform, and you have sort of this metadata over it you could search on. But it's kind of grown since then. And our group uses both sides. So a lot of the work we're going to show today is going to be that catalog piece. We're going to show how everything connects together. You can have a simulation model and go back to the raw lab data that's connected to it. And we'll showcase that in one of our demos. The other piece, though, is when you have a model, you have the content of it. So we don't just want to know what type of model it is. We want to know the data, so we can actually run the simulation. So often you'll hear catalog versus content. But I'm going to change it up a little bit today. I want everyone to imagine that they are at a restaurant, they're sitting down, and a waiter or waitress comes up to you, they hand you a menu. That waiter or waitress is OSDU. It's doing the delivery, going back and forth in order to do this. The menu itself is our catalog schemas. So that's the base of the stuff. So you can look at the menu, figure out you want this steak, broccoli, mashed potatoes. You can see all the different pieces of it to know that you want to order that. And that's the job of the catalog, to help you find the data that you want. You're going to tell the waiter or waitress that. They're going to go back, and they're going to prepare the meal, and they're going to bring it back to you. And so that's where the DDMS is coming. The DDMS is the one that's preparing and sending it back to you. And that's the content. So when we're going through this presentation, we're going to have our first demo is going to be really focused on how can we search through the data, really focus on that catalog side of it, or the menu side. And then the other two are going to be focused more on that content, the actual meats of the data that we're pulling back so we can actually run our simulations. So please pray for us a little bit here, because two of our demos are going to be live, and we're hoping everything works out well. A couple of them are video. We really thought it would be better to do live, so we're risking it, though I do have backup slides in case. So we're going to jump with our Lumi Data Workspace demo here. So this will be one of our live ones. And we're going to showcase our ability to, our catalog side of it. So I want to see, maybe I can zoom in a little bit. Yes. All right. So in order to do the validation for ours, we got some feedback in the spring face-to-face that we should put some real data, or at least do our best to put real data in there. So we were happy enough to know that the Volve Equinor set that was donated has a full reservoir simulation in it. So we're able to use that as kind of a base. And if we can't redo the Volve simulation, then our MVP doesn't work, right? So that's what we're starting here. When you see that chart that Jen was showing, and I didn't want to go all the way that way, you'll see that we have our rock physics models, our saturation function sets, fluid equilibrium, all those different pieces that Jen was showing there. And we can navigate through them. So OSDU has a schema for both. The catalog is there. We can look at it that way. If I come over to one of these records, I can actually start seeing the meat of what we're doing. And a lot of our, come on, we can do it. A lot of the meat is going to be, what are people going to search on? When we're asking what our catalog is going to be, it's what are we going to search on? So in this case, when most of our models kind of look the same with slightly different attributes per it. So we'll see we have like the name, description, source. I'm not going to go too much in the detail. But when you're actually looking for a model, let's say 10 years down the line, you want to find a model, people are going to know, what is this model for? So the model area of interest, it's for the vol field, right? And they're going to know, how was it put together? So we have our basis of modeling that will tell us, and it linked back to other groups. So our RAF group has done a great job creating all of these schemas for raw fluid data. Well, those feed into this model. So we link back to that. So you can say, hey, we have this sample analysis here from the Volve data set. We're going to link into that model, and that's what we're building our model off of. But there may be other data pulled into it as well. So we have the capabilities of connecting it all together for that purpose. OSDU comes predefined with the ability to have documents too, and that's really important because a lot of reservoir modeling right now happens at the document level. So we made sure that we can have the link to documents hooked into it as well. And you can see here quickly that we have a lot of the ability to link back, okay, here's the sample analysis that was done for it. It is for the vol field. I can even go to the vol field and see everything that's done on top of it because of how we're doing the lineage. So from the vol field, I can quickly see that I have fluid models, entire simulation models, rock physics models, saturation function sets, and I'm connected back to all of our other domains as well, such as well and wellbore, right? Because the whole goal of our catalog schema is to show that whole matrix of the data connecting together so you can easily navigate through and find the data. On top of that, we have the capability of doing technical assurance on top of it. We can write data quality rule sets and actually run rules on top of it to see whether or not it's happy. So I wrote a quick rule here, it's 100%, so it's certified as this is a model that is acceptable. And every company can find their own rules on that and stamp any of our work product components or any of these models with that stamp depending on their rule sets. And that's really the goal here. So in this case, I have this rock physics model. I can quickly see that there's at least one simulation model hooked to it. And if I go to that simulation model, this is where you get to like, this is the most important piece of what we've done in MP1. We have this one component that is linking to every single thing. So we can see here we have a grid, a 3D grid that's coming from our reservoir DDMS, or reservoir domain. And our goal here is we have these rock and fluid models. We have this grid. We're splitting it into regions. We're applying models to the grid with certain properties. So I can define the properties like a rel-perm region, a PVT region, equilibrium region, and then say, hey, this rock physics model is being tied to these region codes. The saturation function sets to these region codes, and things like that. So that when the simulator pulls in a simulation model, it knows exactly what to do. It can pull in the grid, it will pull in the models and start doing the magic it does. And it doesn't matter which simulator this is. It can be any of the commercial simulators out there because our job is to create that standardized data. Now, our simulators often, again, work off files. So even for legacy data sets that you may only have in files, you can still use OSDU. You can attach the files directly here. So we can see we have the equilibrium, we have the regions, we have the rocks. So even with our MVP1, you can attach all of your older models here and store them here and start adding the metadata over time. And then we always take advantage, too, of the ancestries. So for example, if you're modeling this in Petrel and you're importing the Petrel, you can actually track that lineage back and actually see the exact project that it came from. If you ever want to pull it back, you want to make changes, things like that. So this is one of the reasons we liked this demo is it really shows how you can navigate through OSDU, see all the lineages together. But at the end of the day, a simulator can't just take this and do anything. It's going to need the actual content, the meats. So now that it knows, okay, I may want this Vol reservoir simulation, now it can put in the order with the waiter and waitress and actually pull back that. So I'm going to actually jump over to our next demo. So I was mentioning that we had this grid, and we actually did load this grid into, or SLB helped us load it into their IVAP tool. So I'm going to show a quick video of the IVAP tool showing this 3D grid coming back from our reservoir DDMS with their new connector. So let me jump over to that. And I will skip over the slides that I didn't need. Good job, internet. Okay, so I'm going to start this. This is going to be a really quick one. There's not much to show here. And I do want to specify this real quick. The dynamic modeling happens really at the end of the workflow. So we already have data from the rock and fluids, wells domain, reservoir domain. So a lot of stuff we're showing actually already exists in the ecosystem, but we're trying to pull it together. So we didn't create, the grid schemas or anything like that, but we are leveraging them in our workflow. So I want to make sure credit's given where it's supposed to be. All right, so started the video, and what's going to happen here is in IVAP, we're going to create a project, and it's going to get created really quickly. And then there you're going to be able to zoom into the area of your interest. So like you saw in the reservoir model, we had our area of interest for that specific model. And you can create a project and you can add attributes to it. Now this can be anything. It could be seismic, well bore, simulation. The goal of OSDU is to bring it all together, right? So this is one of the tools that can show that. So we're using it here to show some of the simulation. But you can even see we saw some segue files there for seismic too. So we'll navigate to the field now, and you'll see there's the outline of the field coming from the master data, and here we can actually start seeing the model come together. So we have our well bores, and we actually have the grid that's coming from our reservoir domain pieces. This is going to be super important, and this is just an example of what a simulator could do, trying to pull that in as well from OSDU. So like I said, it would be a quick demo, but really valuable, and seems like a good tool for filtering and things like that. Unfortunately, we have lots of representatives up here. We were hoping to have one more from SLB. His name was on the front, Yasir. He helped us a lot with his demo, so kudos to him for helping us with that. It was really, really awesome he was able to do that. So now, I think let's go ahead and jump to our next piece, which will be the custom UI that I built that I'm actually going to pass it off to my peer Pierrick to cover.
Yep.
I actually don't think you'll need that. Oh.
No, I think I don't need it. Well, whatever.
Do you want the laser pointer?
So the main issue we have with this, let's say, building a simulation model might be the building, let's say, of the simulation deck, what we are calling the simulation deck. So the way we are taking the different equilibrium model, rock model, fluid model, and assigning them properly to the different regions within the static model. Apparently, I've heard rumor that it might be difficult from time to time to get data out from OSDU. So Zak developed this user interface, which is super smart and which is fully designed to initiate your simulation model from OSDU input. So you start on this, let's say, this home page where you can select the different, where is the pointer? This one, okay. So different models, rock physics, saturation function, fluid models, equilibrium models, and you're building your simulation deck afterward. So you can navigate on the different model, select your different inputs. So for instance, if we look at the rock model, which is split between rock physics and sat function, we can go to the saturation functions, for instance. Then we can see that we have two models which are already available. We can navigate to the first one, the one selected to the demo. We can see we have a couple of, let's say, metadata. So we are still on the content, the catalog side, sorry, and we can see that we have two different content attached. Let's say the file and its DDMS counterpart. We can then go to the content and view it. And then we have a couple of information related to this one more time, some metadata, etc. But ultimately, what we can see the actual model as it's stored within the DDMS. So in that case, this is a relative permeability curves. So that's it. That's going to be taken and built in your simulation deck. So you can check what you are about to select it, coming back to your simulation deck. You see the JSON counterpart being created, and then you can push everything in your simulation deck. And ultimately, it will move to the intersect side by pre-feeding the scripts, the intersect scripts files. And that's it, mainly. Yeah. Yep. Thank you, Zach.
Yeah, so we spent a lot of time not just making sure that we can navigate and do all the lineages and stuff, but actually making sure that we can actually run a simulation, which requires us to have the content in a format that's actually readable. But our goal over MP1 was to be able to initialize a simulation in a simulator. So can we really say that it's done unless we did that? So our last demo is actually going to be showing that in action. So let me jump over to that, and then I'll pass it off to Faroukh. Let me skip this.
We have 4 short videos for you. We didn't want to run the simulator.
Your mic's not on.
Yeah, is it okay now? So we have 4 short videos for you. The first one, we have developed a Python connector that reads the data from OSDU and generates specific simulator-specific files, decks, okay? And then in the second part, we add those files which was generated by the connector from OSDU data into the simulator master data file. We trigger the simulator. And in the third part, we initialize the reservoir, wait a day, run the simulation for a day to get a stable model. And then we look into the print file from the simulator. And in the last part, we load the entire simulation or simulator deck, as well as the results of the initialization in another commercial product. And we visualize the data that we have gone through from OSDU all the way to the simulator. So this is a very simple script that reads the data from the OSDU and generates those files that can be consumed by the simulator. You want to run it? So a very simple script. Once these files have been generated, we look into the files. We open one of those files. Can you pause here? So as you see, these files have been read directly from OSDU. We have a header which shows who has run or generated this deck, what time, from what data partition. And for every data that also we generate, we add a lot of, a lot of, I think, can you pause it again? Mm-hmm. A lot of metadata. So for example, what kind, what was the ID, what was the source of data. We try to augment as much as possible metadata, even to data that is used by the OSU. So if someone in a couple of years look into this file that it was used by a simulator, they know exactly from where this data came, okay? And we have the entire audit trail here. So this is the equilibrium. We have about 11 regions in this model for the Volvo, and we have generated 11 equilibrium regions. And the next one is the rock data for the rock physics and saturation. Again, we have 11 rock physics regions and 2 saturation functions, which defines the relative permeability and capillary pressures. And these are in the format for intersect to be used. Again, same thing, we add a lot of metadata to make sure that we have some type of audit trail from where this data came. So the next part, this is the master data file from Intersect. What we do, we add these files that were generated by the connector to this file in order to trigger the simulator. So we add the rock data and the equilibrium. These are the 2 files that were generated by the connector, read directly from OSDU. And now we go to trigger the simulator. Once we trigger the simulator, as I said, we initialize the model and we run it for a day to get a stable model. And this is the part that the simulator really runs. So this is the print file, okay? We just look into it. At some point, we get all our equilibrium region, the 11 that we defined. And once the model has been initialized, what we do here now, we load the entire simulation deck and the results of the initialization in another commercial product, which happens to be Petrel. Here, we show in the 3D window in Petrel these 11 equilibrium regions that we loaded. Can you run it? Thank you. So these are the 11 equilibrium regions that we loaded into OSDU and feed the simulator. We look into the definition of these regions. These are the same data that we loaded into the OSDU, and also check with the graphic here with the, so all the same. And then we go into the saturation functions. Okay, these are the same relative permeability that I was showing, or Zak was showing. We loaded into the OSDU, consumed to the simulator, and now we are visualizing in the Petrel. Thank you.
Thank you, Faroukh. So we really want to do this kind of exercise. It's kind of over my head as a software engineer. So I'm happy to have experts like Faroukh and the rest of our team. But to us, on the data definition, we're so early in the flow that we often get disconnected from the actual implementation side. So us being able to do something like this to actually say, oh, we're able to actually take data out of OSDU, manipulate it, and get it into intersect and initialize actually tells us, okay, we're doing a decent job here. And so we're going to continue doing that going forward. So for our MVP, we're considering the one to be a success. But we had another 2 weeks ago, another mini face-to-face to really focus on what we want to deliver for next year. And our hope, this one took all year. Our hope is that we're going to start delivering stuff by every face-to-face. So something like this, where we can come give a presentation every single spring, fall. So now me and Jen are going to go over our kind of idea for what we came up with 2 weeks ago. Sorry, it's a little hard to see, but right now we've really focused on the yellow boxes. And some of them you'll see we're going to start expanding on because there's more to a rock physics model than compressibility. There's more that goes into it. Same thing with saturation function set and eventually fluid model as well. But we also want to start bringing in other aspects, particularly from like the well domain. So bringing in the idea of having the definition of a well, knowing the connections and all that stuff, the multi-segment well topology. I could have swore I was going to forget what MSW meant, but I got it. And then the well controls, such as the constraints and the historical controls, the groupings, and the aspects like that. So when we run the simulation, more of those files that Faroukh was showing in that manifest, we could support the actual work product components and the lineage and the searching of those aspects of it. On top of that, we're going to, you'll see up here we have the simulation document manifest. So I showed you that we can already store the documents, but the simulator may use the documents in particular ways. So we needed some way to tell the simulator, here's how I want you to use all of these documents that I have stored. This really gives us the ability to actually run any simulation you want as long as you have the documents loaded to OSDU, even if we don't have work product components and actual like the lineage yet. You can actually put the documents in there, you can put a manifest of how to use the documents, and any simulation should be able to run from there with OSDU behind it. And then we can slowly improve our other attributes to make searching for each of those documents easier.
Yeah, we just want to point out here, you can kind of see for the MVP2, we want to be able to show kind of our progress and updates in the spring summit, and then additionally for the MVP3 with the expectation to do it next year here. And then, honestly, we just want you guys to see kind of the work that we have been putting in for the last year with our expectations of what we will do for the following year, but really show how this can be actually utilized in your business to provide value to your company. So thanks, everybody, for talking. And do we have, I guess we ready for Q&A?
Yeah. What questions do y'all have?
You need a mic, so hold on, we can get someone to get you a mic. Do you guys? Come forward. Not hide in the back.
We are shy.
So I think our first questions are right here in the middle.
Well, first I want to say that's excellent showing it in use. So I'm a reservoir engineer by background as well, so obviously this is the best thing ever. What I'd really just like to ask, I see you made great progress there. Have you also been thinking through how you, because I understand OSDU has lineage and versioning in there, how you're doing that part? And there's two parts. One is, can you say something about how you're doing the versioning and so on, because it looks like milestone models. And the other one is, have you done any thought yet on the profile generation at the end? Because one of our big business issues we have in BP, and I guess lots of people have it as well, is great profile. What went into that? And being able to track back would be extremely valuable.
Yeah. So in our MVP1, I'll start with the second half because we kind of already have that. Our MVP1 fully does that full lineage. You should be able to take that reservoir simulation model and go back to the PVT report coming from the lab or the relative permeability. All that lineage should be there, exact versioning. That should already be there in our MVP1. We have, what I did not show here is we also have parent-child relationships with models. So you may start with your first thought, and then you're like, okay, this one actually didn't work, so you have a second one. And we actually also track that lineage. So you can actually say, I'm on, if you want to, version 30 of this model, and here's all the stuff I've tried. How you implement that will be a company by company, because you could end up with a large amount of storage costs if you stored thousands and thousands of versions. That's up to each company to decide, but we do support that. So whether you're storing just the golden one at the end, or you're storing all the intermediate, or just certain ones, like that's the business decision that has to be made.
If I may, and is there a production lineage as well, the final output one, or is that on your
Correct, yeah. So we do connect to something that already exists in the OSDU platform, the production values and the estimated reservoir volumes. That would be the output of a simulation. And that can also be used in the future. And one thing we didn't mention is our goal at the end of next year is to support basic history matching. So bringing in that production values in order to actually do a better simulation as well.
Yes.
So
of course.
was said, since you don't have a mic, that it can also be tied to a business decision.
I have a question
Thank you.
here. You have shown that pretty much this workflow was enabled by this bespoken connector, right? wasn't supposed to those applications intersect in Petrel reaching OSDU straight instead?
Yeah, so ideally that's what we want, right? Right now, all the simulators that have worked with us work off a file. So they need, in order to run, they need to generate a file. And ideally, though, they would go directly to OSDU. We can't show that now because our stuff isn't released yet. Our goal is to get what we showed today released later this month by the 14th deadline. Once that's released, then we can start, the vendors should be able to start reaching out and trying to see how they want to do it. And it could be they decide they want to recreate something similar to what Faroukh does. SLB may come up and say, hey, I just want to generate files, or they could go directly to it themselves.
Okay.
But every vendor can decide their implementation with our data model.
Okay. The final question I have is, how much of this solution, this workflow that you just showed, it's tightly coupled to Schlumberger? How can we leverage interoperability?
Yeah, so I knew that question was going to come up because we showed SLB stuff today. None of the stuff is tied to SLB. We try, in every single meeting, in my meeting, we specifically mention, okay, what about the other simulators? How is this to SLB specific, things like that. Unfortunately, while we've invited a lot of other simulator groups, SLB is the one that shows up the most. So they get their opinions heard. But we really try not to make it specific. There's no reason that you shouldn't be able to use our data model for any other simulator as well.
Yeah. If I can add one thing, the content schemas, so the way the models are represented are stored in the RAFS DDMS, which is OSDU and non-SLB. As part of the MVP1 definition, we always say that we want to validate it against at least 3 different simulators. Of course, Intersect and Eclipse, but also we want to have a third non-SLB simulators, even more. So I don't know the whole diversity of potential providers we have in the room, but if you have any interest to join the initiative with your simulators to prove that it works, you're more than welcome.
Yeah, we're happy to help map to your simulators, do all of the work to do that proof case, because we are not trying to build a data tool for SLB.
Hi, my name is Devashish Chatterjee from Catalyst Data Management. I got a similar question like him. It's about the vendor unlocking, because your subject said interoperability. It's a great presentation. Thank you for showing us that. But my request would be that inside the OSDU forum, there is an active group called Interoperability, where there are 2 instances, one AWS, one Azure, where multiple vendors and operators are trying to work together and trying to show that a workflow is possible without getting engaged to one vendor and having the data properly shared. In my laundry workflow, I don't want to have the same company's washer, same company's dryer. I want to have complete freedom and flexibility. So I welcome you all to come and join that group and reproduce your workflow by engaging applications from different vendors and different operators even. CCMAG, for example, right? Thank you.
Yeah, no, I agree. And it's one of the reasons that we really pushed to show my custom UI too, to show that it's not just SLB products. I built my own thing. I was able to use the data model and do the specific things like pull the content. So yeah, I think we will reach out to you, Devashish, and see how we can get into that group.
And also, one thing, schemas are not designed based on the SLB simulators, okay? We try to have a coverage from many simulators. So really what is important is the data coverage in OSDU, which goes more beyond the SLB simulators.
Yeah. Yeah, and and our demos today was just to show it in action. I do want to say we're not promoting the usage of any of these applications. I'll just say that now. What other questions do y'all have?
Hi, I'm Dylan from Bill AI. I guess my first question is, what made you brave enough to do 2 live demos? But the real question is about that custom UI that you built that was initially for the validation of the schema. How far are you hoping to go with that? Is that just going to stay as it's for your team to test out, always for validation purposes, or do you see it going somewhere?
Yeah, I don't see it going commercial because I don't know enough about it in order to write a commercial app around simulation. It really is just for validation. And it's more of me. Unless I can see it happening in action, I don't think it's going to work. So that's why I built it. But definitely not going to be a commercial application or anything like that. Happy to use it as an example of how people can work with APIs, though.
Okay, so I have one extra question here because we've been talking about the interoperability group, and then folks have been saying, oh, well, what about the other applications? One, you did build that entire UI without utilizing anything from SLB, but two, y'all keep saying, come and join us if you're from another company or you want your voice heard. What time can they come do that, and what day of the week?
So there is 2 meetings. There's the reservoir management meeting, which is Wednesday from 9 to 10. Is that right? Yeah, okay. And then there's the dynamic meeting that Zach has from Thursdays, 9:30 to 10:30. Sometimes we have some extra meetings just to ensure that we're trying to move on the pace that we had promised. So, for example, maybe tomorrow morning. But yes, please join us. There's a fluids meeting as well from 8 to 9 that they're currently finalizing some of the fluid model stuff as well. So by all means, please attend.
Yeah. And anyone that's interested in joining our groups, just let me know. I'm happy to do a quick catch-up. Like we can do a one-to-one. Let's get everyone on the same page so that you can come in ready to go. But we definitely want more involvement if we can get it. Anything else? Thank you, everyone.
Thank you.
Thank you.